This is just me, Mr. Wee. I'm going to go through the last bit of notes that we have for week 1 in month 1 of integrated math 2. It's a lot of numbers there. Okay, so let's see. This is the stuff that we couldn't go over in class, and I expect you to know for your exam. And not just that, just to know from the lessons and whatnot this month. Let's see if I can kind of get this coordinated. Okay, so I believe, we're on 0-10 still, and we were looking at, I think, square roots and so forth. I think there's a little bit more. That's an ampersand for and then dot, dot, dot. I'll just say that, okay, for now. All right, so we're going to look over this thing called conjugates, okay? And what this means is, let's say I give, this is a sample problem. This is 3 with 5 minus root 2, okay? Now, in math, you can't have radicals on the denominator. It's okay to have it in the numerator, but you cannot have it in the denominator. It's not necessarily wrong, but a lot of mathematicians say that I think this is actually illogical and actually doesn't make sense once you get into the deeper levels of math. We're not going to get into NSI, but we just know that we can't do it. So let me just show you what you're going to have to do to change this, okay? So the rule is, you're going to basically multiply and get rid of this root 2 on the bottom by doing this. You're going to write the same thing. You're going to multiply it. You're going to multiply the bottom by 5 plus root 2. It's whatever you have, just change the sign in the middle, okay? And the thing is, you're going to have to do it not only to the bottom. Whatever you choose to do to the bottom, you have to do it to the top. Now, why is that? Well, let's just kind of review really quick. Anything divided by itself is equal to what? Anything divided by itself is equal to what? Anything divided by itself, 4 divided by 4, 3 divided by 3, 1 divided by 1, is technically 1, right? All of this is equal to 1, like a giant number 1. If you think about it, you're multiplying this guy by a giant 1. This is the exact same as this on the bottom. So you're multiplying this whole thing by a giant number 1. Okay? What that means is you're not changing the value of this, are you? You're just multiplying it to 1, but you're changing the way it kind of looks, like this. It's like saying 3 divided by 5. If I multiplied both the numbers by 2, it's going to be 6 over 10. This and this are not different in value. They just look a little bit different. This is considered quote unquote simplified. This is not the simplified version, but they're the same value. Same here. You're multiplying this guy by the same value up and down, so that way you don't change the value at all. You're just changing the way it looks. So that's just a side note, by the way, okay? So let's go ahead and see what happens. So here we're going to have 3 times 5 plus root 2 divided by this, 5 minus root 2 times 5 plus root 2. And let's see what's going to happen. Let's deal with the top part first. I'm going to leave the bottom part alone. I mean, once you get good at this, you can do everything all at once. But I'm just going to show you how to do it just step by step the slow way. So the first step is the distributive property. We distribute this 3 to the 5 and the root 2. So that's pretty simple. 3 times 5 is 15. And on the top, it's going to be 3 times root 2. It's going to be 3 root 2. That's not tricky. That's not too bad. The bottom part's what's really tricky. A lot of people don't know how to take care of these, and you've learned formulas before. Let me show you the easy way, okay? It's simply this. It's the distributive property. Like, you take the number on the outside and you put it on the inside, but you just do it one at a time with both of these numbers. With these numbers, watch. 5 distributed to this 5 and this root 2. What do you get? 5 times 5 is 25, and then 5 times root 2 is plus 5 root 2. Okay? Now, what you're also going to do is you're going to take this number and distribute it to the other two numbers inside. That's it. So this is minus root 2, so this distributes this. Minus 5 root 2 is what you're going to have. And then this minus root 2 times root 2, that's going to be minus root 2. Minus root 2 times positive root 2 is going to look like this. Negative times positive is going to be a minus again. And then 2 and 2 are under the umbrella, so they're going to be 2 times 2. Okay, so let's simplify again what we have. 15 plus 3 root 2 over 25. 5 root 2 and minus 5 root 2 are going to cancel out. These are combined like terms. They both contain root 2 and a whole number on the outside, and they're the same thing. 5 root 2's minus 5 root 2. These will cancel out, so you're going to have 0. This, however, is minus, let's multiply the 2 and the 2 on the inside. It's the square root of 4. And if you know in your heart, or no, if you just know by memory what the square root of 4 is, it's 2. So it's 15 plus 3 root 2, 25 minus 2. And then that simplifies back to 15 plus 3 root 2 divided by 23. That's your final answer, okay? Now, let's go back. So that's it. But let me give you a few things. Let's go back to here, root 4. You might have learned this rule. As long as, so let's go back to 2 times 2. As long as you have a pair of numbers that are the same, just a pair under the square root sign, you could pull it out. So that's why this rule still works. The square root of 4, if you just memorize it, is 2. Or if you just do the factorization rule that we kind of talked about in class in the previous part, or in the lesson, the other video, part 1 basically of this lecture, lesson, whatever, of week 1, you would remember that any pair of numbers underneath the square root sign are automatically pulled out. That's a note. That's one note that you should consider. Okay. Also, people ask me, Mr. Wee, so let's go back and kind of look at what we just did. It's like, Mr. Wee, you just did this. Okay, so let's backtrack. You just did this. You multiplied, sorry, this is 3 over 5 minus root 2. You just multiplied this by 5 plus root 2 over 5 plus root 2, which is a giant number 1. Anything divided by itself is just 1. So this is a giant number 1 covering this fraction, okay? How come you didn't do this, Mr. Wee? This is really confusing that I have to write the same thing on the bottom with a plus sign. How come I can't just do this? Multiply this guy by this. 5 minus root 2, the same thing, Mr. Wee. Because some people might be thinking, hey, these are square roots. I'm going to get rid of the square root if I multiply these two. And it still goes by that rule, Mr. Wee, that this anything divided by itself is 1. But let's see what happens, okay? So let's check it out. 3 times 5 minus root 2. So this is just a proof. You don't have to do this for any of the problems. But just so I can explain to you why this does not work, like this will not work. I will cross this out in just a second because it won't not work. You're going to see why. But I just need to show you and prove it to you. Okay? 5 root 2, 5 minus root 2 times 5 minus root 2. I won't be able to do this for every problem in the future, but hopefully I can. So I can kind of help you out. So this is, let's distribute this out. This would be 15 minus 3 root 2, okay, which would be okay. It's a little bit different from what we had before, but as long as the bottom kind of does its thing, and I don't know, like you'll see, it'll be all right. So 5 times, let's distribute this first number to both the numbers opposite. So it'll be 25 minus 5 root 2. Not bad, okay. 25 times root 2 is minus 5 root 2. Over here is negative 2, or negative root 2 times 5, and negative root 2 times negative root 2. Let's look. You're going to have negative root 2 times 5 is minus 5 root 2. And then over here is minus root 2 times minus root 2. That's going to be plus root 2 times 2. Sort of like what we had before, but look here. Watch what happens. 25, let's combine like terms. This is a like term. This has a root 2. This has a root 2. This is 5. So this is 5, negative 5 root 2. This is also minus 5 root 2. Minus 5 and minus 5 will not cancel out this time. It will give me minus 10 root 2. And then over here, we know that this is the square root of 2 times 2, which is the square root of 4, which is just 2. This is not acceptable because the whole point of this was to get rid of the square roots in the fraction. Remember? With my other one, oh, I think I lost the page. That's not good. Let me see if I can find, oh, here it is. In my other example, when I did it times 5 minus root 2 times 5 plus root 2, I ended up with 5 root 2 minus 5 root 2. This cancels out, which is great. The whole point of doing all this work was to get rid of the square root. Back over here, though, when I do it the way that we think should be good, it did not work. It ended up with a value with the root 2 on the bottom. Okay? So that's why multiplying it by the same exact denominator isn't quite right. Okay? So this method does not work. If you're going to do conjugates right, the conjugate means you multiply the bottom times itself, but you're going to change the sign in the middle of it, and you're going to do the same thing up top. Okay? So I'm going to stop right there. I don't want to confuse you. All right? I want you guys to practice that. If you guys have any questions, come and see me during tutoring. I'm going to go ahead and stop this video, and you guys have a great day and weekend. You guys have a great week, and just be great. Bye.